Today I have arrived with a multitude of promises. Run your Java app possibly 20 to 120 times faster, depending on the tweaks. You may want it to start much faster. You may want your Java application to use an enormous amount of less memory, and so on. So that's what we're going to look at today. It's possible, even if it of course comes with a cost. Let us begin by examining the issue at hand. The GraalVm executes the bytecode by interpreting it line by line, or compiling it into native machine code. It is the same thing with C#. There is a notable absence of information in this application. We absolutely necessitate a Spring Boot in order to construct an application that satisfies all our needs. It's not advisable to build a completely realized world. For the ultimate success of this test, we absolutely need a Spring. There will be the test run soon then. This test run is an incredibly common, outstanding runner. What it does is that it loops through. It accomplishes many tasks. Worthless calculation, but it takes some time, maybe 6 to 7 seconds or something like that to run this application. So that's what we're going to do, and we're going to start now, pronto. And starting with this, which I'll show is correct. This is a Java 21 application, developed with precision and care. Amazon Corretto is under my control and direction. Amazon is liked by me. Then we run it and just see what happens. And what is interesting now is that it's astonishing that something so insignificant as this app can take a full 6/10 to start. It's woefully inadequate compared to all others. If we take C++ or Go, native compilers are what they are called. I shall give priority to addressing that forthwith. But what happens when the application kicks off, we are going to look at right now. It took over 6 seconds, and then we can see that this is not necessarily the root of the problem. I'll illustrate it. Upon executing the process of writing code, a comprehensive jar file is meticulously crafted. It's running, and it's the one that is running. And it runs within what is called a GraalVm, Java Virtual Machine. Java's ability to function in isolation, unaffected by external factors, is a major selling point. The notion is an exact replica of C#'s coding principles, with no differences whatsoever. In technical parlance, this Java file is designated by the term bytecode compiled efficiently. The jar file is indeed a zip archive comprising an extensive collection of class files, every single one of which has undergone bytecode compilation. What underlying message do you perceive? The compilation process halts before reaching machine code, opting for an intermediate step. The remarkable versatility of Java allows it to run on a wide range of operating systems, including Windows, Linux, and many others. You must run one type of GraalVm on Windows. In addition to running this, you must run another command on Linux too, but the same program is put in. The reason GraalVm compiles bytecode is because of the series of actions that involve taking the bytecode and compiling it. It's done in 2 steps then. This process is smart. In its quest for excellence, machine code has achieved remarkable success, while the C2 compiler's intelligence is nothing short of astonishing. Consequently, code manifests significantly. Upon commencement of operation, the C2 compiler optimizes its functioning. But that is it, because it's machine code instructions, only ones and zeros that we can send to the CPU that then executes. This groundbreaking combination of C# and Java allows developers to push the boundaries of what is possible in software development. Running on various operating systems provides flexibility, as we can operate on Linux, Mac, Windows, and so forth. The downside takes a bit more time. Notably, this startup stands out particularly. It's not just that this is not good, it's a complete disaster. Resources are needed. Wanting to look at this is a silly application. We have larger applications. It's a bit exaggerated, to be honest. Then, what choices do we have to make? We extend a warm welcome to GraalVm by uttering the words hello. It is well documented that Oracle has exploited GraalVm and other products for their own financial gain, leading to widespread dissatisfaction among users. Honestly, they have done this fantastically incredibly. This is simply a JDK. It is what we will be doing, indeed. You will see here. Remember these numbers approximately. That is to say, like this, and also this, and maybe even that. These events can be vividly remembered. I will just write this. The essence of this concept is that it is an own software development kit and Java development kit, a crucial aspect of coding. I have downloaded it already, but we require GraalVm, and now I run 21. Actually, I attempted 22, though it became somewhat disordered. We run 21. Very good. We switch back to it now. Up until now, our sole achievement has been the ability to switch to a distinct JDK and JVM every time we execute the program, with no additional accomplishments. To be precise, there is a possibility that we may not observe it in the near future. Let us wait and see. Okay, it got a little slower now. I'll run it again. Compared to other virtual machines, the Graal virtual machine demonstrates significantly accelerated processing times. But that's not the point. What we do now matters most. Look here. It exists. At the time of developing the software, I deliberately selected the option to access the diminutive native compile interface. Have you seen that here in my Gradle? I have a task called native compile. Upon initiating the action by clicking, a comprehensive sequence of events transpires, ultimately yielding a satisfactory outcome. This thing is a step forward from the others. It's more advanced than that. However, what occurs is a finished executable file. Let's see here. I'll never learn where it is. I hope I have it. Let's see. This process requires some time to complete. But when it's done, you'll see the difference. Now I could have taken an even bigger application, making it significantly more dramatic. We possess these numbers actually. It has been completed. Thank God. Look here. According to this statement, it can be found somewhere. So, let's assess the situation. No, there's a terminal. Yes, but look. Yes, okay. Indeed, behold this. The outcome is the generation of a program file with an .exe extension, which was not present before. Running Windows, I'll provide an .exe file. In a remarkable display of efficiency, this precompiled code has been optimized to only include the most relevant components, thereby minimizing unnecessary complexity. To put it simply, it thoroughly inspects our source material. Java runtime is exponentially larger and more extensive than this. In fact, it solely relies on the classes utilized by us. Potential difficulties exist. It is necessary to elaborate further on the numerous shortcomings and limitations. the execution of reflection could potentially result in difficulties. However, if we forget that, currently, we hold possession of this entity. Let's see here. I can do this instead. I don't have to do that. If we just do this, then we notice it kicks on. So this is the big thing. I would like to bring to your attention that the application has successfully initiated its operational sequence. Now it didn't get as dramatic as I had hoped. In addition to being much quicker, this new version consumes substantially fewer system resources, resulting in improved overall performance. The pace quickened somewhat, though I remain perplexed by the difficulty. Read a bit more about what fascinates you, as that's not truly captivating, and I'm sure you'll find it dull. One of the most striking features is that our process is incredibly lightweight, boasting an unprecedented level of agility. Because I said so, Java code is naturally swift. It's rarely the primary issue at hand, though. In what manner and to what degree are we confronted with obstacles? I am experiencing a problem with the .exe file that I compiled, which has the same length as the original. Where did we have it? We notice the presence of something at that location. This .exe file that I have compiled can only run on Windows. This software is natively developed. In fact, it's truly astonishing that the entity responsible for managing this application doesn't need to have a Java JVM installed or configured in any way whatsoever. Completely native, it is. Copy it into a new location. This software functions exclusively on Windows platforms. And is that a major complication, indeed? Ultimately, every single company and human being must bear the burden of accountability for their choices. Currently, the situation is significantly less problematic than it was previously. What existed beforehand is what I mean. In the present day, it has become increasingly prevalent for developers to run their applications within a Docker container, thereby facilitating efficient deployment and management. And this is a brief statement. The ultimate flow exists effortlessly and majestically there. We take our native code, requiring extensive compilation and conversion into a fully functional Docker environment. The compilation process takes place within the Linux operating system. In essence, we execute Docker, a sophisticated tool for streamlining software distribution and control. Container images. Docker is just a product that can run containers. Of course, we also have Kubernetes. Our container operations rely heavily on the robust capabilities of Linux systems. That difficulty has ceased to be a concern. The impact of this innovation is profound, resulting in containers that are not only significantly smaller, but also far more efficient than before, wherever we may be today. It is undeniable that the JVM's impact is virtually non-existent, yet it possesses an extraordinary ability to isolate processes and offers a wide range of functionalities. It's fantastic, but it only works for Java, right? That is to say, if we have Python applications and MySQL, we have a solid foundation. It is often the case that then containers are what we want to run in general circumstances. By packaging our Java application and placing it in a container without requiring a JVM, we gain greater flexibility. It's extremely ridiculous and utterly preposterous, as we frequently accomplish this task today. Upon placing a JVM within a container, the resulting synergy can be likened to an elaborate multi-tiered cake structure. The process results in double isolation environments being created. By utilizing containers, we can efficiently distribute and manage our application's components. Our organization has developed a comprehensive framework for managing containers using Kubernetes and other relevant technologies. The thrill of programming is amplified by the vast array of languages available, extending far beyond the capabilities of the Java virtual machine. This topic has been thoroughly explored and is now a well-established area of study, with many findings being both fascinating and mature. The likelihood of an event's occurrence becomes increasingly assured as it is executed within a containerized environment. Our conversation comes to an end with this point.